Hello. Okay, so this is my video key for the chapter 2, standardized test practice. So I'm going to read each question and then I'm going to solve each question. So number 1, at Medina Middle School, 2% of the students ride bikes to school. If 950 students attend Medina Middle School, how many students ride a bike to school? So this is a percent proportion problem. Just a reminder, our percent proportion is percent over 100 equals part over whole. So we were given a percent. Okay, it told us 2%, so 2 over 100 of the students ride bikes. 950 students attend Medina Middle School. Is that the part or is that the whole? That's the part, 950. Okay, so we are looking for the part. So I'm going to start by drawing arrows towards what we don't know. Okay, and then I see, can 100 become 950? So if this was a trickier number, we might not be able to figure this out because we can't with a whole number, but with a decimal, if we multiply by 9.5, right, times 9 will get us to 900, and then times 0.5 gives us half of it, so 50 would be 950. We're going to do the same thing to the top, times 9.5. So if we do 2 times 9.5, we will find how many students ride a bike at school. So I'm going to do 9.5 times 2. 2 times 5 is 10. 2 times 9 is 18, plus 1 is 19. So we have 1 digit behind the decimal in the problem. We need 1 digit behind the decimal in the answer. 19 students ride their bike to school. That's answer C. All the answers were pretty close to there, so I did have to solve that to answer that one. Number 2, the formula C equals 5/9 times F minus 32 can be used to convert a temperature from degrees Fahrenheit to degrees Celsius. Which of the following is closest in value to 5/9? So 5/9 is a fraction that's less than 1, and it's a little bit greater than 1/2, I can tell, because 5 is greater than half of 9. So I know for sure it's not going to be F. F is 5.9. That's way bigger than 1. 5/9 is less than 1. I also know it's not going to be 4. Again, 5/9 is 1. 5/9 is less than 1. 4 is way bigger than 1. And it's not going to be H either. So without even doing anything, I've solved I. 5/9 must be close to 0.56. So if I didn't know that, I could also solve this by making 5/9 into a decimal. We know that every fraction is a division problem. So this says 5 divided by 9. So we're going to put 5 in the box, and we're going to put 9 outside the box. How many times does 9 go into 5? Well, 0 times. We're going to add a decimal and a 0 after 5. How many times does 5, or bring that decimal up, how many times does 9 go into 50? Well, it goes in 5 times because 9 times 5 is 45. Minus equals 5. I'm going to add another 0 and bring it down. How many times does 9 go into 50? Well, again, 5 times. That's going to keep repeating, 0.5555. If we remember, we write it like this in bar notation with the line over the 5. But this answer must have rounded, 0.56. So either way I solved, I would have gotten I. Number 3, Sanford's shoe store received a shipment of shoes for its newest location. The manager determined that 35% of the shoes were athletic shoes. What fraction of the shoes were athletic shoes? So 35% is less than a half. Let's look at all of these. Are all of these less than a half? Yeah. Oh, this one's not. 13/20 is not less than half. So we can get rid of 13/20. We know 35% is not going to be equal to 13/20. 50% would be half, and 35% is less than half. So that's how I know it's not going to be 13/20. Half would be 10/20, so there's no way it's D. So let's convert 35% to a fraction. Percent means out of 100, per 100. So we're going to write 35 over 100. Well, there's no answer that says 35 over 100. It's probably simplified. So let's simplify. What can we divide 35 and 100 by? Ooh, 5. I know that because 35 ends with a 5, and 100 ends with a 0. If a number ends with a 5 or a 0, we can divide it by 5. What's 35 divided by 5? Well, 7. And what's 100 divided by 5? That's 20. 7/20. Hey, that's A. So our answer is A. 35% is equal to 7/20. Number 4, Mark got 18 out of 25 questions correct on his science test. What percent of the questions did he get correct? So this is, again, is going to be our percent proportion. Percent over 100 equals part over whole. So this time we don't have a percent. We're not sure what the percent is. We do have a part. He got 18 questions right. That's the part he got correct. And whole, there were 25 questions on the test. Okay. Now let's draw arrows towards what we don't know. Can 25 become 100? Yeah, if I multiply by 4. So I'm going to do the same thing to the top. 18 times 4 will give me my percent. 18 times 4, 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. 72. So Mark got 72% of the questions correct. Let's move on to number 5. The graph shows the elements found in Earth's crust. What fraction of Earth's crust is silicon? So right here I see silicon is 28%. So I need to convert that to a fraction. Well, before I jump in, let's do some thinking. 28% is less than half. Okay, are there any of these choices that I can eliminate? Ooh, I is equal to half. I know I can eliminate that. 28% is less than half. 50% would be half, so there's no way it's equal to 1/2. Now, I can't eliminate any of the other ones, but if I had to guess, I gave myself a better chance. Let's convert this to a fraction. 28% means out of 100, 28 per 100. So 28 out of 100 is our fraction. Again, that's not one of the choices. Let's simplify. What can we divide 28 and 100 by? Well, I know we could divide by 2 because these are even numbers. 28 and 100 are both even numbers. They end with even numbers or 0. But I was thinking 4, okay, because I know 28 can be divided by 4. And 100, I'm pretty sure in the last problem we just did, 25 times 4 is 100. So let's divide the top and bottom by 4. Okay, 28 divided by 4 is 7, and 100 divided by 4 is 25. 7/25. Oop, there it is. G. Nice. Okay. Number 6, the fastest fish in the world is the sailfish. If a sailfish could maintain its speed as shown in the table, how many miles could the sailfish travel in 6 hours? So if it gets 0 hours, it travels 0 miles, which makes sense. 1 hour, it travels 68 miles. Wow, so it goes like 68 miles per hour. That's like the speed of a car on the highway. How long could it travel in 6 hours? Well, I know it travels 68 miles in 1 hour. Right here, I have 5 hours. It traveled 340 miles. So if I just need to add 1 more hour, how far does it travel in 1 hour? It travels 68 miles. So I need to add 68 miles to the miles. 340 plus 68. Ooh, before I even jumped into this, I should have eliminated some answers. I know it can't be A or B because in 1 hour, the sailfish travels 68 miles. So how in 6 hours would it only travel 6 miles? Or how in 6 hours would it only still travel that same 68 miles? So those I can definitely eliminate. C and D both seem reasonable, but let's see. 340 plus 68, 0 plus 8 is 8, 4 plus 6 is 10. I'm going to regroup that one. 408 miles, which is answer C. Let's go to number 7. Carlita planted 4 flowers in 9 minutes. About how many flowers can Carlita plant in 36 minutes? So we have that she can plant 4 flowers. I'm just going to put F. In 9 minutes, I'll put M. How many flowers can she plant in 36 minutes? How many flowers? That needs to be lined up on top. 36 minutes on bottom. Let's draw arrows towards what we don't know. Can 9 become 36? Yeah, if I multiply it by 4. I'll do the same to the top. 4 times 4 I know is 16. So she can plant 16 flowers in that 36 minutes. Number 8, what is the ratio of people to buses? I need to pay attention to order here. People to buses. Order matters. So how many people does it give me in the table? It gives me 150 people. How many buses does it tell me in the table? It gives me 6 buses. Let's see if this matches any of the options. 150 to 6. Ooh, this one's close, but the order's swapped. This gives the ratio of buses to people. Order matters. So there's no way it can be H because that switched the order. And then 156 to 6 is not going to be correct either because it's 150 to 6. So I is incorrect. So it's either F or G. I'm going to write it as a fraction because it looks like it wants us to simplify. I see some different numbers in there. The first number goes on top. The second number goes on bottom. 150 to 6, 150 to 6. Now let's divide the top and bottom. So I'm assuming I'm going to need to divide by 6 because both of these have a 1 in them. So I need that 6 to become 1. 6 divided by 6 is 1. Now I have to do 150 divided by 6. How many times does 6 go into 1? It goes in 0 times. How many times does 6 go into 15? It goes in twice. 6 times 2 is 12. Minus equals 3. Bring down that 0. How many times does 6 go into 30? It goes in 5 times. 6 times 5 is 30. Minus equals 0. We get 25. 25 to 1. It needs to be in that order. 25 to 1, which is G. 25 to 1. G. Let's go to the back. Number 9. A school population was predicted to increase by 50 students a year for the next 10 years. If the current population is 700 students, what will the enrollment be after 10 years? Before we jump in, let's take a look at these multiple choice answers. So there's already 7 students there, and the population is going to grow. There's no way it's going to be A, and there's no way it's going to be B. Those both reduce the population. We know the population is going to grow. So this year it started at 700. Okay, so next year, 1 year, it's going to grow by 50 students. Then the second year, it's going to grow by 50 students. How about the third year? 50 students. And it's going to keep doing that for how many years? 10 years. Okay, whoops, I shouldn't have done that line there. Okay, so I'm going to do 700. Instead of adding 50 10 times, I could do plus 50 times 10. 700 plus 50 times 10. Okay, because that is 50 students per year for 10 years. 50 times 10, I need to do that first. It's multiplication and it's in parentheses. 50 times 10 is 500. And 700 plus 500 is 1,200, or C. Number 10, Pam is painting a total of 45 square feet in her bedroom. If she has painted 60% so far, how many square feet of the bedroom does Pam still need to paint? Okay, so we have percent over 100. This is going to be a percent proportion problem. Equals part over whole. Okay, so I have a percent. It gave us 60%. Okay, and then part is what she's finished so far. I don't know what she's finished so far. I do know that there's 45 square feet total. Okay, so here's my percent proportion. This will tell me how many square feet she's painted. Let's draw our arrow towards what we don't know. Right here, the question mark. Can 100 become 45? Ooh, that one's tricky. No, not that I can think of. Can we think of a stepping stone that 100 could become that can then become 45? Ooh, I just thought of 5. 100 can become 5, and then 5 can become 45. So let's use that as a stepping stone. We're going to make 100 become 5, and then 5 become 45. How can 100 become 5? If I divide by 20, and then how can 5 become 45? I need to multiply by 9. So I'm going to do both of those things to the number on top. First, I'm going to divide by 20 60 divided by 20 is 3. And then I'm going to multiply by 9. 3 times 9 is 27. So she has painted 27 square feet. Is that what the question asked us? No. How many square feet of the bedroom does Pam still need to paint? So she's already done 27. So how many does she have left? Well, I need to do 45 minus 27. 5 minus 7 I can't do. I need to regroup. This becomes 15. 15 minus 7 is 8. 3 minus 2 is 1. She has 18 square feet left to paint. Ooh, it was trying to throw us off because do you see right here there was a 27? That would have been the answer if it said how many square feet has she painted. But it says how many square feet of the bedroom does she still need to paint? Number 11, a class of 26 students ordered the items shown in the table. If the class agreed to split the cost evenly, about how much will each student pay? So first we need to figure out how much all this stuff is going to cost together. So they bought 27 donuts at $1.25 each. Okay, so it was $1.25 for one donut. How much is it going to be for 27 donuts? Well, how do we make one become 27? We multiply by 27. So we need to do $1.25 times 27 to find the cost of the donuts. I'm going to do that over here. $1.25 times 27. 7 times 5 is 35. 7 times 2 is 14, plus 3 is 17. 7 times 1 is 7, plus 1 is 8. We add Jerry because we're doing the second line of multiplying. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. Let's add these together. 5 plus Jerry is 5. 7 plus 0 is 7. 8 plus 5 is 13. 1 plus 2 is 3. There's 2 digits behind the decimal in the problem. I need 2 digits behind the decimal in the answer. It's $33.75 for those 27 donuts. Whew, we got some pricey donuts. Gallons of orange juice. There were 5. Well, it did say about in this problem. The gallon of orange juice is $1.99, but isn't that really close to $2? So I'm going to say it's $2 for 1 gallon of juice. How much is it for 5 gallons then? Well, how can 1 become 5? Multiply by 5. Do the same thing to the top. That I can do in my head. It's $10 for 5 gallons of juice. And then we have 1 package of napkins for $1.50. Now let's add these together. So the donuts cost $33.75. The juice cost $10. I do need to line up my decimal. There's an invisible decimal after the 10 here. So I'm going to place that invisible decimal and add these ghost zeros. And then the napkins were $1.50. Let's add. 5 plus 0 is 5. 7 plus 0 plus 5 is 12. I'm going to bring the decimal straight down. 1 plus 3 plus 1 is 5. 3 plus 1 is 4. It's going to cost $45.25 for everything. So everyone in the class is splitting this evenly. And there's 26 students. Okay? $45.25 split between 26 students. So we're going to divide by 26. How many times does 26 go into 4? 0 times. How about 26 into 45? I think only once. Let's do the subtraction. Ooh, I know my answer is going to start with 1. Okay, 5 minus 6 I can't do, so I'm going to need to regroup. 19. Bring down the 2. How many times does 26 go into 192? Well, 25 would go into 208 times. So I'm going to say 7. 26 times 7 is 42. 6 times 7 is 42. 7 times 2 is 14, plus that 4 is 18, 182. And that was 7 times. So it's going to be $1.07 something. Since it asked us about, I know my answer is going to be C. I'm going to stop dividing right there. 150 is pretty close to 1.7, and then we'll have another digit. But I don't even need to keep going because I'm given multiple choice, and it said about. Okay, 2 more. Refer to the table below. Here's the Williams family budget. If the Williams family has a monthly income of $3,000, how much do they spend on clothing and entertainment? This is another percent proportion problem. We have percent over 100 equals part over whole. So our percent, the percent for clothing and entertainment is 12%. So we're going to put 12 over 100. And then did they give us a part or a whole? They told us the family has a monthly income of $3,000. That's their whole. That's all the money they get in a month. Okay? So we're looking for how much they spend on clothing and entertainment. It's 12%. Let's draw our arrows towards what we don't know. Can 100 become 3,000? Yes, it can. Well, if I multiply by 3, it becomes 300. But we need an extra 0, so we have to multiply by 30. 12 times 30 will give us question mark. 12 times 30 I think I can do mentally, because what's 12 times 3? 36. Add that 0. So they spend $360 on clothing and entertainment each month. Perfect. One more question. Copy these models below. Both models have the same area. So model A and model B. Shade 0.25 of model A. How could we say that decimal correctly? We could say 25 hundredths. So shade 25 hundredths of model A. Well, if there were 100 squares, I could easily just shade in 25, but I don't think there's 100 squares. Let's count. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. There's 36 squares. So I'm going to set up a proportion, because in this, the whole is 100, but in mine, the whole is only 36. Okay? So I'm looking for how many squares I need to shade in of the 36. Let's draw arrows towards what we don't know. Can 100 become 36? No, it can't. So what can 100 become that can then become 36? Well, I know what numbers can become 36. 4 can, 9 can. Oh, 4. 100 can become 4 if we divide by 25. And 4 can become 36 if we multiply by 9. Do the same thing to the top. Divide by 25 first, it becomes 1. And then multiply by 9, we get 9. So I need to shade in 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. I shaded in 25 hundredths of model A. Part B, shade 1/3 of model B. Okay, 1/3 of model B. So if there were only 3 pieces, I could just shade in one of them, right? But unfortunately, there's more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 total pieces, so I'm going to set up a proportion again. How many do I need to shade in? Can 3 become 9? Ooh, I can. I don't even need to use a stepping stone. Multiply by 3. Multiply the top by 3. I need to color in 3 pieces. 1, 2, 3. Hey, that makes sense, because couldn't I have made this into thirds by going like that? So I color in one of those pieces, 1 out of 3. Part C, which model has the greater fraction of shaded area? Explain your answer. So we're comparing 1/3 to 25 hundredths. Well, I simplified 25 hundredths kind of. I divided the top and bottom by 25. That simplified it to 1/4. So what's greater, 1/3 or 1/4? Well, let's think about it. I know fractions are kind of backwards. 1/3 means I get 1 piece of cake that was split between 3 people. 1/4 means I get 1 piece of cake that was split between 4 people. Ooh, I think I'd rather have the 1/3, because these pieces are going to be bigger because there was less people to split it between. So 1/3 is greater than 1/4. So let's make sure we answer it. Which model has the greater fraction of shaded area? That was model B, was 1/3. Model B, B/C for because 1/3 is greater than 1/4. And we're done with our Chapter 2 standardized test practice. Thanks for watching.